the early 18th century, Britain was not yet the workshop of the world. It was a landscape of market towns, rural labor, coastal trade, and scattered craft production. Most work was still done by hand. Most power came from muscle, wind, and water. Production was limited not by demand, but by energy. Beneath the surface of this landscape, however, lay an enormous geological advantage. Britain sat on vast and accessible coal seams. In places like Northumberland, Durham, South Wales, and the Midlands, coal had been mined for centuries on a modest scale. It was used for heating, brewing, metalworking, and salt production. But in the 18th century, something changed. Population began to rise. Urban centers expanded. Timber supplies tightened. Traditional fuels grew more expensive. Coal, once considered dirty and inferior to wood, became increasingly essential. London alone consumed extraordinary quantities by the early 1700s, supplied by coastal shipping from northeastern coalfields. At the same time, Britain was undergoing commercial expansion. Overseas trade grew. Agricultural productivity improved. Capital accumulated. A financial system capable of funding risk began to mature. The stage was set for transformation. But that transformation would not begin with factories. It would begin with water. Early industrial development depended heavily on water power. Textile mills clustered along fast-moving rivers. Ironworks were built near streams that could drive bellows and hammers. But water had limits. Rivers froze. They flooded. They could not be relocated to where labor and markets were expanding. Geography imposed strict constraints. Coal offered something different: portable energy. It could be transported, stockpiled, and burned anywhere. But mining deeper coal seams created a serious problem. As pits descended underground, groundwater flooded the workings. Extraction slowed. Costs rose. Entire mines were abandoned because water could not be removed efficiently. This technical obstacle would prove decisive. In the early 18th century, inventors and engineers began developing mechanical solutions to pump water from mines. The most significant breakthrough came with improvements to steam-driven pumping engines, associated with figures such as Thomas Newcomen and later refined dramatically by James Watt. Steam engines were initially designed to solve a mining problem, but in doing so, they unlocked something far larger: coal-powered steam engines, and steam engines enabled deeper coal mining. The result was a feedback loop. More coal allowed more steam power. More steam power allowed more coal extraction. By the mid-18th century, Britain had begun an energy transition. For centuries, societies had depended on organic energy systems: wood, crops, animal power. Now Britain was turning to fossil fuel on an unprecedented scale. The shift was not sudden, but it was cumulative. Each new pit, each improved engine, each expanding town reinforced the momentum. What emerged was not merely an increase in fuel supply. It was the foundation of a new economic structure. Coal was dense, concentrated energy. It could power machines that worked longer, harder, and more consistently than any human or animal labor. It freed production from the rhythm of daylight and seasons. The implications extended far beyond mining. Iron production expanded as coke, derived from coal, replaced charcoal and blast furnaces. Urban manufacturing districts began to grow. Transportation networks adapted to move heavy bulk fuel across the country. Coal was no longer one commodity among many. It was becoming the central pillar of Britain's industrial system. This transformation did not yet feel revolutionary to those living through its earliest stages. Mines expanded gradually. Engines improved incrementally. Workshops mechanized piece by piece. But beneath this incremental change lay a profound structural shift. Britain was reorganizing its economy around underground carbon. The story of industrial Britain, therefore, is inseparable from the story of coal. It is a story of geology meeting technology, of energy reshaping labor, and of a nation learning to harness buried sunlight accumulated over millions of years. This was the beginning of a new energy regime, and once established, it would alter the scale of production, the organization of work, the structure of cities, and Britain's position in the world. By the late 18th century, coal was no longer simply a resource. It had become a strategic necessity. Britain's expanding economy was beginning to depend on continuous, reliable energy, and the demand for coal intensified accordingly. Industrial growth placed new pressures on supply. Textile manufacturing, especially in cotton, expanded rapidly in regions such as Lancashire. Steam engines, increasingly efficient after the improvements of James Watt, were no longer confined to pumping water from mines. They began powering rotary machinery inside mills. Production could now move away from rivers and into towns and cities. Iron production placed additional strain on coal fields. The use of coke in blast furnaces, pioneered earlier in the century, allowed furnaces to grow larger and hotter. Output expanded dramatically. Iron rails, tools, machinery, and structural components required enormous quantities of fuel. Coal was both the source of heat and the foundation of the metallurgical system itself. Urbanization added another layer of demand. Cities such as Manchester, Birmingham, and Glasgow expanded at unprecedented rates. Coal-heated homes, powered workshops, fueled bakeries, and supplied gas lighting as the 19th century progressed. The growth of population translated directly into growth in consumption. This mounting demand reshaped the geography of Britain. Coalfields became industrial cores. South Wales developed vast mining districts tied closely to ironworks and ports. The Midlands formed a dense industrial zone, where mining, metalworking, and manufacturing. Northern England's coal seam supported both local factories and coastal export trade. Transportation networks evolved to accommodate bulk energy. Canals were constructed to link pits with factories and ports. Later, railways would depend on coal not only as cargo but as fuel. The relationship between coal and transportation became circular. Railways increased coal distribution, and coal powered the locomotives that expanded railway systems. As mines deepened, engineering challenges multiplied. Ventilation became critical. Explosive gases accumulated underground. Roof collapses and flooding remained constant threats. The drive to increase output often ran ahead of safety improvements. Production targets intensified physical risk. Did you know that the modern world as we know it was forged in the heart of Britain, powered by a humble black rock? That's right, I'm talking about coal. Before the steam and smoke, Britain was a quiet, agricultural nation. But deep beneath its green hills lay the fuel that would ignite a revolution. It all started in the 18th century. Innovators like James Watt didn't invent the steam engine, but they perfected it. And what did these new, powerful engines crave? Coal. Lots of it. Suddenly, mines were dug deeper and faster than ever before. Canals and then railways spread like a web across the country, all to carry coal from the mines to the factories. This black gold powered everything. It smelted the iron for bridges and ships, drove the looms and textile mills, and even lit up the newly bustling city streets. Britain became the workshop of the world. Its economy exploded, and cities like Manchester and Glasgow swelled with people seeking work. This was the birth of the industrial working class, a seismic shift in society that created immense wealth and opportunity for some. But this progress came at a steep price. The dark, satanic mills weren't just a poetic phrase. Thick, black smoke choked the cities, turning buildings gray and causing widespread respiratory problems. Rivers were polluted with industrial waste, and the landscapes around the mines were scarred forever. This environmental legacy is something we're still dealing with today, from powering an empire to fueling a climate crisis. The story of coal in Britain is a powerful reminder of how one resource can shape a nation's destiny, for better and for worse. It's a complex, dirty, and absolutely fascinating piece of history that still impacts our lives every single day. Thanks for watching. If you found this journey into the past interesting, give this video a like and subscribe for more deep dives into history. See you next time. Have you ever wondered what really powered the Industrial Revolution? It wasn't just steam engines and factories. It was something black, dusty, and buried deep underground. Coal. In the 19th century, Britain became a nation built on coal. This single resource didn't just fuel machines, it completely rewired the country. Entire towns sprang up around coal mines, and a new working class was born. Their lives dictated by the rhythm of the pit. Railways crisscrossed the landscape, not just for passengers, but two whole mountains of coal to power the factories that churned out goods for a global empire. It was a cycle of extraction and production that accelerated change at a dizzying pace. transforming Britain and the world forever. Think about that the next time you flip a light switch. It all started here. Thanks for watching, and don't forget to subscribe for more deep dives into history. Did you know that a simple machine, powered by steam, completely reshaped our world? Before the 1800s, traveling just a few dozen miles could take an entire day. But then, the steam locomotive chugged onto the scene, and everything changed. Suddenly, goods, people, and ideas could travel faster and farther than ever imagined. This wasn't just about speed, it was a revolution. Cities boomed as factories got raw materials from distant lands, and fresh food could reach tables hundreds of miles away. It connected communities, created new industries, and literally laid the tracks for the modern world we live in today. The rhythmic chugging of the steam engine wasn't just a sound, it was the heartbeat of progress, powering an era of unprecedented growth and innovation. Think about that next time you see an old train. Thanks for watching, and don't forget to subscribe for more amazing stories from history. The shipping industry underwent parallel change. Steamships, fueled by coal, gradually supplemented and then replaced sail in key commercial routes. This reduced dependence on wind patterns and shortened travel times. Britain's maritime network expanded in reliability and reach. Coal bunkering stations appeared at imperial ports, embedding fossil fuel infrastructure into global trade routes. Coal extraction itself became more mechanized. Improvements in winding gear, pumping systems, and underground haulage increased productivity. Output rose steadily through the first half of the 19th century. By mid-century, Britain was producing tens of millions of tons annually, far exceeding earlier generations' expectations. These early shifts were not purely technological. They altered labor structures. Mining communities expanded rapidly. Entire towns formed around pits. Work underground became increasingly specialized. Hewers cut coal at the face. Trappers managed ventilation doors. Surface workers sorted and loaded output. The division of labor deepened. At the same time, industrial capital accumulated in unprecedented quantities. Railway construction required large-scale financing. Mining enterprises attracted investors seeking reliable returns. Insurance markets expanded to cover industrial risk. The coal economy was interwoven with financial innovation. Energy density changed economic logic. A single steam engine could perform the work of dozens of laborers without fatigue. Machines operated beyond daylight hours, extending productive time. Seasonal limits weakened. Production planning became more predictable. Britain's international competitors observed these developments closely. Coal-powered industry allowed Britain to export not only goods, but technology. Engineers traveled abroad. Railways were built across Europe and the Americas using British expertise. Coal and steam became symbols of industrial modernity. Yet this period of early shifts also revealed structural vulnerabilities. Mines grew deeper and more dangerous. Explosions caused by fire damp claimed lives. Flooding remained a persistent threat. Efforts to regulate safety lagged behind production demands. Urban areas dependent on coal developed new social patterns. Housing clustered near factories. Pollution intensified. Soot settled on buildings and clothing. Respiratory illnesses became common in industrial districts. The energy system was delivering growth, but it was also imposing environmental and human costs. By the mid-19th century, Britain's economy had reorganized itself around steam power. Coal was no longer an input among many. It was the foundation of transportation, manufacturing, metallurgy, and urban life. The early shifts had established a new equilibrium, one in which fossil fuel consumption determined the scale and speed of economic activity. And once that equilibrium was reached, the next phase would push it to unprecedented levels of expansion. By the middle decades of the 19th century, coal was no longer driving isolated industries. It had become the operating core of the British economy. The system was now self-reinforcing, integrated, and national in scale. Railways spread rapidly across the country, binding coalfields to ports, cities, and manufacturing districts. Lines radiated outward from industrial centers and converged in London. Coal traffic dominated freight movement. Trains carried fuel to factories, returned with finished goods, and extended the industrial web further into rural regions. Mining outputs rose to meet this growing demand. Annual production climbed into the tens of millions of tons and continued rising through the century. Coal was exported in large quantities to continental Europe and beyond. British coal powered foreign railways, steamships, and factories, extending the country's energy influence far beyond its shores. Environmental transformation intensified. Mining scarred landscapes with spoil heaps and urban air pollution became a defining feature of industrial cities. Smoke abatement debates emerged, but economic dependence on coal limited meaningful reform. By the late 19th century, Britain had become the world's leading coal producer and exporter. Energy consumption per capita was unmatched. The country had effectively built a civilization organized around combustion. Coal was no longer merely powering industry. It had shaped national policy, labor systems, urban design, global trade networks, and military strategy. The system had taken over, embedding fossil fuel dependency at every level of economic and social structure. The scale of this transformation would become even clearer when measured in numbers. By the end of the 19th century, the scale of Britain's coal economy was without precedent in human history. At the start of the 1700s, national coal output had been measured in a few million tons per year. By 1800, production had risen dramatically. By 1850, it had multiplied several times over. And by 1913, on the eve of the First World War, Britain was producing more than 290 million tons annually. No earlier society had extracted energy from the earth at such magnitude. Environmental transformation intensified. Mining scarred landscapes with spoil heaps and urban air pollution became a defining feature of industrial cities. Smoke abatement debates emerged, but economic dependence on coal limited meaningful reform. By the late 19th century, Britain had become the world's leading coal producer and exporter. Energy consumption per capita was unmatched. The country had effectively built a civilization organized around combustion. Coal was no longer merely powering industry. It had shaped national policy, labor systems, urban design, global trade networks, and military strategy. The system had taken over, embedding fossil fuel dependency at every level of economic and social structure. The scale of this transformation would become even clearer when measured in numbers. By the end of the 19th century, the scale of Britain's coal economy was without precedent in human history. At the start of the 1700s, national coal output had been measured in a few million tons per year. By 1800, production had risen dramatically. By 1850, it had multiplied several times over. And by 1913, on the eve of the First World War, Britain was producing more than 290 million tons annually. No earlier society had extracted energy from the earth at such magnitude. The state began to take greater interest in the industry. Parliamentary inquiries examined working conditions, child labor, ventilation standards, and safety practices. Reports revealed the scale of underground labor and the risks miners faced daily. Regulation remained limited at first, but public awareness increased. Coal's dominance reshaped urban infrastructure. Gasworks converted coal into gas for lighting streets and homes, extending activity into the night. Iron foundries operated continuously. Engineering firms built larger and more efficient engines. Cities became permanently illuminated in mechanized environments. The interdependence between sectors deepened. Coal fueled iron production. Iron built railways. Railways transported coal. Steam engines pumped mines and powered factories. Each part depended on the others. Disruption in coal supply could halt production across multiple industries simultaneously. This integration was visible in regions such as South Wales, where coal mining, ironworks, and ports formed tightly connected industrial corridors. Similar patterns emerged in northern England and the Scottish lowlands. Coalfields were no longer peripheral landscapes. They were central arteries of economic life. Labor organization evolved in response to scale. As mines expanded and ownership consolidated, workers formed associations to negotiate wages and conditions. Strikes and collective action became part of industrial relations. The coal industry, employing hundreds of thousands by the late 19th century, became a focal point of labor politics. Technological improvements continued. More efficient boilers, reduced fuel waste, ventilation systems improved marginally. Mechanical cutting devices began to supplement manual extraction toward the end of the century. Yet despite innovation, much of the physical labor remained grueling and hazardous. Britain's global position reached its height during this period. Coal output underpinned industrial exports, naval power, and imperial infrastructure. Steam-powered warships required steady fuel supplies. Coaling stations were established along imperial sea routes, embedding fossil fuel logistics into strategic planning. Ever wondered what really powered the Industrial Revolution in Britain? It wasn't just steam engines and factories. It was black, dusty, and buried deep underground. I'm talking about coal. Before the 18th century, wood was the main fuel source. But as forests dwindled, Britain turned to its vast coal reserves. This shift was a game changer. Suddenly, there was a powerful, abundant energy source to fuel the iron industry and, most importantly, the new steam engines. But how do you move millions of tons of coal? The answer came chugging along on iron tracks. The railways. The growth of railways was explosive, creating a vast network that connected mines to factories and cities. This incredible synergy between coal and rail didn't just move goods. It moved people and ideas, shrinking the country and accelerating progress at an unprecedented rate. Cities like London and Manchester swelled, their skies darkened by the smoke from countless coal fires heating homes and powering industries, transforming Britain into the world's first industrial superpower. Thanks for watching, and don't forget to subscribe for more. Iron and steel production expanded in parallel. Blast furnaces operated at higher temperatures and greater capacity. By the late 19th century, Britain had become one of the leading producers of iron and steel, industries inseparable from coal both as fuel and as coke. Exports formed a significant portion of output. British coal was shipped to France, Germany, Scandinavia, the Mediterranean, and beyond. It powered foreign fleets and rail systems. In so many years, exports accounted for tens of millions of tons, reinforcing Britain's role as a global energy supplier. The density of energy released by coal transformed productivity calculations. A single ton of coal contained energy equivalent to 2 years of sustained human labor. When multiplied by millions of tons, the aggregate effect was immense. Britain's economy was no longer constrained by agricultural output or forest resources. It drew instead on fossil reserves laid down over geological epochs. These numbers also exposed vulnerability. Economic fluctuations affected demand sharply. When industrial output slowed, coal production fell, wages declined, and mining communities suffered immediate hardship. The industry's scale amplified both prosperity and instability. Accident statistics reveal another dimension of scale. Thousands of miners were killed over the course of the 19th century in explosions, collapses, and flooding incidents. Safety improvements reduced some risks over time, but fatality rates remained significant compared to many other occupations. Environmental measurements, though less systematically recorded at the time, were evident in urban life. Soot, deposition, smoke density, and river contamination were visible markers of consumption levels. Observers commented on darkened skies and blackened stonework as symbols of industrial magnitude. By the early 20th century, Britain had built an energy-intensive civilization. Coal heated homes, powered factories, moved trains, drove ships, and fed furnaces. The figures were not abstract statistics. They represented a society fundamentally reorganized around extraction and combustion. The sheer scale of production and consumption marked Britain as the first industrial fossil fuel state. And with that scale came consequences not only economic, but human. Behind the rising production curves and export figures stood the human structure of the coal economy. Mining was physically demanding, repetitive, and often dangerous. Work underground required long hours in confined spaces with limited light and ventilation. Miners lay on their sides to cut coal from narrow seams. Dust filled the air. The constant presence of methane gas created the risk of sudden explosion. Flooding and roof collapses were persistent threats. In the early 19th century, women and children worked in some mining districts, hauling coal carts through low passages or operating ventilation doors. Public investigations gradually exposed these conditions. Legislative reforms restricted child labor underground, but economic necessity continued to shape family participation in mining communities. Wages fluctuated with market demand. In years of strong export growth, miners could earn comparatively stable incomes. During downturns, wages fell sharply because many mining towns depended almost entirely on a single pit or company. Economic contraction could affect entire communities at once. Housing in coal districts was often built quickly and cheaply near pit. Rows of terrace cottages clustered around collieries. Basic sanitation and overcrowding contributed to health problems. Industrial air pollution compounded respiratory illness, particularly in urban mining regions. Community life developed around the rhythms of the industry. Shift work structured daily routines. Mutual aid societies and early trade unions emerged to provide financial support in cases of injury or death. Religious institutions, social clubs, and cooperative stores formed part of a shared working culture. Have you ever wondered about the true price of the power that built our modern world? Let's dig into the history of coal. For centuries, coal was the engine of progress, fueling the Industrial Revolution and lighting up our cities. But this black diamond came at a tremendous human cost. Deep beneath the earth, miners faced unimaginable dangerous give-ins, explosions, and toxic gases were a constant threat. These harsh conditions sparked some of the most powerful labor movements in history, as workers fought for safer conditions, fair wages, and basic dignity. In tight-knit mining towns, a unique sense of community solidarity was forged through hardship. But the legacy of coal also includes serious health consequences, like black lung disease, which affected generations of miners. The story of coal is a complex tale of innovation, struggle, and resilience. It reminds us of the human stories behind the energy we often take for granted. Thanks for watching, and don't forget to subscribe for more deep dives into history. For industrial Britain as a whole, the human cost was absorbed into economic growth. Rising national income and global influence depended in part on labor performed out of public view, beneath the surface of the land. Coal was both a material resource and a social system, sustained by communities whose work remained largely invisible to urban consumers. The human consequences were therefore complex. Coal brought employment, stability, and community identity to many regions. It also brought danger, vulnerability to economic cycles, and long-term health burdens. As the 19th century gave way to the 20th, Britain's dependence on coal remained profound. But new forces were beginning to reshape the system once again. By the early 20th century, Britain's coal-based system faced new pressures. The industry remained vast, but its dominance was no longer technological change, global competition, and political reform began to reshape the energy landscape. Electrification marked a significant transition. While electricity generation initially depended heavily on coal-fired power stations, the shift altered how energy was distributed and consumed. Instead of steam engines driving individual factories through belts and shafts, centralized power plants supplied electricity across expanding urban grids. Coal was still burned, but its role became more concentrated in large generating facilities.